हम लोगों ने ट्रांसड्यूसर से शुरू किया था, तो ट्रांसड्यूसर को देखते आएंगे क्योंकि दैट वी हैवंट सीन ऑन द स्क्रीन। Screen shared. Can you see my screen?
Yes, sir.
Okay. So just go on reading about this. We have already discussed. अगर कुछ question आएगा तो पूछेगा, then I will explain. We have already done that. थोड़ा जल्दी जल्दी पढ़िएगा, लेकिन बहुत ज़्यादा टाइम है। प्रेशर से इलेक्ट्रिसिटी बनता है। When the crystal is compressed, potential difference is created across the surfaces. If the two surfaces are connected with a wire, there will be a current. Potential difference होता है, और शॉर्ट सर्किट करेंगे, क्लोज सर्किट करेंगे तो करंट होगी। नेक्स्ट,
सर आई नहीं नेक्स्ट स्लाइड।
व्हाट स्लाइड यू आर सीइंग?
हाँ सर अभी आ गई
आ गई
सर अभी।
हाँ, थोड़ा स्लो होता है डेटा ट्रांसफर होने में। नेक्स्ट, स्लाइड 38। नेक्स्ट, कोई क्वेश्चन होएगा तो जरूर पूछिएगा। नेक्स्ट, स्लाइड 40। ये जो रिंग जैसा बना हुआ, दैट इज द क्रिस्टल। In the diagram, the signal is transmitted upwards, but when inverted, it will transmit downwards, which is what is happening in case of ship's transducer. Next, next, slide 42. Everybody understanding what you're reading?
Yes, sir.
Explain. Explain कीजिए please. Try. चुप मत बैठ जाओ यार. जवाब ही नहीं दे रहे. चलो ठीक है, मान लिया, समझ गए. Next, slide 44. Magnetostrictive transducers.
सर एक बार पीछे वाली स्लाइड दिखाना.
Yes.
ठीक है सर, थैंक यू.
What was your point of attention here?
सर ये रेड लाइन पढ़ना था, रेड लाइन पढ़ना रह गया था.
Okay, so चलो क्वेश्चन नहीं पूछते हैं आपसे, आप लोग जवाब नहीं देते. जवाब नहीं देते हैं तो मजा नहीं आता. Next, 44. Next, this is what is magnetostriction. See the size of the box. When magnetic field is applied, the molecules get arranged. All the molecules try to attract each other, and in doing so, the size of the box or size of the bar, ferromagnetic material that is, becomes small. So you can see the vibration. If magnetizing force is applied and removed alternately, that is by alternating current, then this kind of situation will develop. The bar will start contracting and expanding, contracting and expanding. Vibration will be there. Next, next, Next. This transducer is internal installation. That means the hull is not breached. There is no hole in the hull. It is put on the plate itself, hull plate itself. Next. 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 These are the discs. This is the coil. When you apply AC of frequency F, vibrations are there as 2F, twice the vibration in one cycle. Next. These are the advantages. Very often the question is asked, what are the advantages and disadvantages of two types of transducer? Next. Next. Some review questions for you.
सर वो लास्ट स्लाइड का सेकंड पॉइंट सर प्लीज समझा दो
थोड़ा माइक्रोफोन नजदीक करके बोलो भाई.
सर लास्ट स्लाइड का सेकंड पॉइंट सर प्लीज एक्सप्लेन कर दोगे प्लीज.
Okay. Loss occurs twice per sounding, resulting in weak echo. Because the installation is here, the pulses must get transferred through the steel plate, and when receiving again through the steel plate, it has to go back. So the loss happens twice. That is what it is saying.
सर वो 50% किसके लिए बोल रहा है सर? ये अबाउट 15% ऑफ टोटल. सर अबाउट 15% जो किसके लिए बोल रहा है सर? ये पावर आउटपुट प्रेस, ये थोड़ा समझा दीजिए प्लीज सर.
Depending on the thickness of the hull, if the hull is more thick, there will be 15%. अगर पतली होगी तो ज्यादा होगा, और मोटी होगी तो और कम होगा ट्रांसमिशन. This 15% is generally for about 12 mm plate. 12 mm की प्लेट जो होती है उसके थ्रू तकरीबन 15% ट्रांसमिशन हो पाता है. बाकी सारा यहीं पे खत्म हो जाता है। 85% भीतर में वाइब्रेट करके रह जाता है, 15% ट्रांसमिशन होती है नीचे की तरफ।
यस सर, थैंक यू सर।
मतलब मैं जितना तेज से बोल रहा हूँ वो पूरा का पूरा आप तक नहीं पहुंचेगा, ओनली जितनी तेज बोल रहा हूँ उसका 15% ही आपको सुनाई पड़ेगा। जैसे आप तो बोल रहे थे ठीक से, मुझको ठीक से सुनाई नहीं पड़ा, क्यों? क्योंकि दूर से बोल रहे थे, माइक्रोफोन दूर था या कुछ था, तो कम सुनाई पड़ा। दैट
Yes,
इज
sir.
आई एम रिसीविंग लेस पावर। नेक्स्ट, basic principle you have done. How determine the depth? You have done C into T divided by 2. Characteristics, we have done pulse length, frequency, PRF, beam width, and some external characteristics which affect the performance is propagation of waves, seabed, attenuation, etc. etc. We have also seen the types of transducer. We were just doing it. Okay. This one point should be understood, not going into why and how. We will just note down where the transducer is fitted. It is below the hull, of course. But below the hull also, where should it be fitted? There are basically two considerations in placing the transducer. One is that it should be away from the sources of noise, जहाँ पे ज़्यादा vibrations नहीं हो, शोर नहीं हो, तरह तरह की आवाजें नहीं आ रही हो, उससे दूर हो. Also, it should be away from the sources of air bubbles. Air bubbles can be created from the hull side when the water is hitting the bow. The water starts to churn. There is a lot of turmoil in the water, and that creates bubbles that you have seen in the wash of the propeller also. So the transducer should be away from this. Why? Because we have already talked about the noise sources. Aeration we have talked. अगर bubbles के सामने होगा तो aeration के chances होंगे. अगर vibrations और other kind of noises के नजदीक होएगा तो printing में वो unwanted prints आता रहेगा. So transducer should be fitted somewhere away from this. 100% तो फिर भी नहीं हो पाता, but depending on the size of the vessel and the speed of the vessel, there are some prescribed locations where the transducer should be fitted. Most likely place is from the bow about 1/8 to 1/4 LOA of the ship's length. So these are something which you should just remember. There can be a lot of debate about this. So we are avoiding that. We just note it down. Medium size ships, 100-150 meters. Depending on the draft also, if it is not too heavy, I mean too deep draft, then foremost position जहां पे हो सकता है. The ships which run slow, 3/4 length from the bow. That means 3/4. Sometimes there are two transducers fitted. In ships which are very long, there can be one transducer forward, one transducer aft. The recorder will be one. You can switch between aft and forward transducer. When you are selecting aft, this will show aft reading. What is the depth in the aft? If you switch to forward, it will show the forward draft. There should be no ambiguity which draft you are reading. So there will be indication on screen as to which draft you are reading. If there is a sloping surface, you may get lower depth in the forward, more depth in the aft, or any which way. If you have a digital display, there may be a split screen जिसमें forward aft अलग अलग दिखा रहा है एक साथ. IMO recommends that there should be no ambiguity in reading the draft, whether it is forward or aft. Clear होना चाहिए कि forward का draft देख रहे हैं, sorry depth देख रहे हैं या aft का. Then oil tankers. Oil tankers, the cargo space is all air. Tanks are there in the forward. These are not the places where electronic devices are to be installed. So forward of the engine room, somewhere here, that's where the transducer is placed. There are limitations, constraints. ये और इधर कर ही नहीं सकते, इधर कर नहीं सकते, तो यहाँ पे लगा सकते हैं. That's something like below the pump room in general. The piezorestrictive transducer or electrorestrictive transducer, when the hull is braced, the lower plate of the transducer is flush with the hull, मतलब उसके बराबर में होता है, बाहर नहीं निकला हो, बहुत ज्यादा भीतर नहीं हो. तो वहां पे अगर वैसे फ्लश होगा विद द हल प्लेट, देन के की वैल्यू 0 भी हो सकती है, जो हमने देखा था फॉर्मूला में, दैट कैन बी 0. टाइप्स ऑफ डेप्थ इंडिकेटर हमने बात किया था. एक होती है इकोमीटर. विल नॉट ड्वेल ऑन टू दिस बिकॉज इट इज नाउ फिनिश्ड, इट इज नॉट यूज्ड. What we have is the echograph, which we have already discussed. Just a small review of the echograph. When you are reading, it should create an image in your mind as to what is happening. Go on, please read. If you have any question, to ask. Next. This is basically saying the stylus speed is at the half of the speed of the acoustic wave through salt water. जितने देर में पल्स जाके आता है, उतनी देर में स्टाइलस 0 से मैक्सिमम रेंज की तरफ जाता है. नेक्स्ट. Wait a second. Next, this is electromechanical ecograph. Inside the window glass that you can see is the paper, and on the paper you can see the readings of the depth. Of course, there are so many controls here. We'll be talking about some of them. When you open the cover, all that mechanism can be seen inside: the motor, pulleys, stylus, etc., etc. Here, in this case, the stylus is probably hidden either here or here, depending on which side to which side the paper is moving. The stylus cannot be seen because it is covered, but otherwise it is there inside. Recording. This, of course, you have seen. So the recording clearly shows the profile of the seabed. This is historical representation. अभी यहाँ पे इतना है, पहले ऐसा था. The current reading can be seen at one corner. This side में stylus होगा. That is the place where current reading is. Digital ecograph is working on the similar principle. Only there is no stylus, there is no belt, there is no motor, there is no pulleys. What is there is a screen. स्क्रीन के भीतर भीतर में एक डॉट, छोटी सी छिपी हुई डॉट चलती रहती है नीचे की तरफ, which cannot be seen. It is inside what we call the tracing spot. When the signal is received, converted into electrical signal, and it is received by this, the dot becomes bright and shows the marking. So the recording is seen on screen. So processor से ये होता है, processor is generating a tracing spot exactly the same time when the pulse is beginning. When the pulse begins, the tracing spot starts at 0 point. Again, it is moving downwards, as we have already seen, at the speed of half to that of the acoustic wave. जितनी देर में सिग्नल जाके वापस आती है, उतनी देर में स्टाइलस 0 से मैक्सिमम की तरफ जाएगा. So principle is same, execution is different. Next, next. So this is how an electronic display may look like. You are getting the profile also, the graphical display, and you are also getting it in digital format. Why we are having only ecograph now, and why ecometer, not the ecometer? Because ecometer was not able to keep records. It was only showing instant depth. There is no profile reading there. There have been some, disadvantages. So more than that, ecograph has got more advantages. So this should be understood clearly why ecograph परमानेंट रिकॉर्डिंग होती है, पेपर के रूप में है, आप उसको रूल बना के रख देंगे. यू कैन ऑलवेज रेफर बैक. ऑल इकोज आर डिस्प्लेड. दैट मीन्स जो पहले की डेप्थ थी, उसके पहले की डेप्थ थी, उसके पहले की डेप्थ थी, सारा कुछ एक साथ स्क्रीन पे होता है. How the depth is changing can also be seen graphically on screen or paper. For visiting the same place again, maybe you can refer back to the recordings and you can find out how the depth here, how the depth is changing. So profile of the seabed can be referred to again at a later stage when probably visiting the next time. Ranging and phasing. This is the normal operation that we have discussed. सिंक्रोनाइजेशन होती है. पल्स जब स्टार्ट होता है तो जीरो लाइन पे होता है स्टाइलस. स्टाइलस मूव करता है हाफ स्पीड से. सिग्नल जाके टकरा के सीबेड से वापस आती है. That signal converted into electrical pulse is given to the stylus. Stylus makes the recording. I think it should be clear to read on. Next, next, we have seen the problem with the ranging. That's what it is. So this is the problem, and that is solved by means of phasing. Phasing eliminates this problem. As you can see, in each range scale, the difference between upper and lower limit is the same. That means the paper always represents the same depth on scale. And because of this, the stylus is at constant speed. Next, next. This drawing we have seen yesterday on board, on whiteboard. So when you're answering this question, ranging and phasing, you should make this diagram not to scale, but at least to describe what we are talking about: the four sensors placed, the magnet, the stylus, etc., etc. When there is activation, it activates the processor and oscillator. A signal goes there, oscillator generates the signal, and it is given to the transducer. Transducer transmits the signal. Next. So this particular range, which was also in ranging, ranging में 0 to 50 था, यहाँ भी 0 to 50 है. So in this case, both are operating the similar way. But when you select higher range, in that case, the pulse is advanced by an amount equal to the upper limit of previous range. Upper limit of previous range was 50. So the pulse is transmitted even before the stylus is coming at 0. The stylus is behind the 0 point by 50 meters. All right, so we have almost spent the class in revising what we did yesterday and therefore yesterday or the previous two classes. Some of the controls we will talk about. You should be familiar with these controls because you may have to operate the echo sounder and on board. So of course there is on off switch, echo sounder on, echo sounder off. Then there is range selector switch. You can choose the range that your range of the depth that you are reading. Remember that this is an important control. Your range in the echo sounder must be such that you are in the, the depth you are reading should be within the range selected. If you are reading, let us say 80 meters of depth, on the chart there is 80 meter, and the range scale selected by you is 0 to 50. There will be wrong reading. There will be wrong reading in your echo sounder. If you are reading that 80 meter and the range selected is 100 to 200 meters, then also there will be wrong reading. So you should be something like in the range of 50 to 100 meters if you are reading 80 meters of depth. When the depth increases, you should also change the range scale so that depth you are expecting to read is within the range selected. Next one is paper control, paper speed. As we know, the paper is moving on x-axis. Paper was moving like this. So we can increase the speed or we can reduce the speed. If we increase the speed, the profile that we are reading is good, but the paper finishes fast. For the same thing, if you are running the paper slow, of course धीरे चल रहा है तो paper तो देर तक चलेगा, but the reading, same reading what you are going to get is something like this. So the profile will be compressed in a smaller area. So reading will not be as clear as when the paper is fast. So fast paper gives you better profile, but paper finishes quickly. Slow speed of the paper gives you poor kind of profile of the seabed, but paper will last long. So normally when we are more concerned about the profile, how the depth is changing, which is in the coastal areas, we generally increase the speed. When in deeper waters where there is not so much of difficulty of depth, we can reduce the speed. So we try to get best of both the things. Fourth one is stylus speed control. We have already talked about it. Stylus speed must be maintained at 750 meters per second, which is half the speed of the acoustic waves. We know the reason very well now. We have talked about it multiple times. When talking about gain block diagram, we also talked about the gain control. Sensitivity control or gain control is basically the ability of the echo sounder to read the depth. When we have the amplifier which is given a signal, we have a gain control which can increase or decrease the signal as per our requirement. More signal means darker printing, small signal means light printing. If you reduce the gain too much, no printing. If you reduce the gain too much, full paper getting black. So gain has to be adjusted so that you are getting just the right kind of printing. So that is gain control. We have already seen in the formula that if we were reading depth of the water, not the UKC, but depth of the water, then the draft of the ship should be added to the reading. So there is a provision given in the eco sounder itself that you can add the static draft, and the displayed speed will start showing you water depth. वो उतना ऐड करके बताएगा. यूकेसी जो ट्रांसड्यूसर रीड कर रहा है, that plus the draft that you have set manually will be added to the depth, and the recorder will show you water depth. There can be unit selector also, whether you want to read the depth in meters, feet, fathom, etc. So that is as per your choice. Fixed marker is a push button, spring loaded push button. There is this recorder. The stylus is making the print like this. If you press the fixed marker, then a current is given to the stylus constantly, continuous electrical signal is given to the stylus. Doesn't matter where it is. So वो ऊपर से नीचे आता हुआ black mark करता जाता है. That means because of the fixed marker, you have created a line on the vertical line on the paper. Now this line is basically an event marker. यहाँ पे ये था, ऐसा हुआ था, वो था, इस position पे था. We were crossing the bar. Bar is basically a junction between the river and the sea. तो बहुत बार river से mud वगैरह आती है तो जम जाता है. Under the seabed, you may have a profile like this, where the silt is deposited like this. So this is called bar. The ship may be coming from this side and crossing the bar. So when crossing the bar, how much was the depth? That can be marked on the fixed marker. By the fixed marker, sorry. Then we have transducer selector switch. As we have seen in the bigger ships, there can be two transducers. So we can choose between the forward and aft transducer which depth we want to read. Then there is panel brilliance control knob. During the daytime, nighttime, you want different kind of light. So dimmer light is there. Basically variable control with which you can adjust the light. So these are some controls of the eco sounder. So next class we'll be talking about operational maintenance. What are the normal maintenance to be carried out on eco sounder, so that it is giving you perfect kind of recording. Also we'll talk about some errors, and with that we'll be done with the eco sounder. So one class for eco sounder, one more class, and then we will start EGDIS, which is the last topic. INS IBS paper baat hogi. So I think 3 classes in the next week we should be okay. If not 3, maybe 4 class. ठीक है?
Yes, sir.
Any questions?
No, sir.
Any questions? If no, then lunchtime. Bye bye. Have a great day, all of you. Signing off.
Thank you, sir.
Thank you, sir.
Thank you, sir.